Today we're going to talk about relations and functions, specifically how to graph relations and how to identify functions. So to start off, remember that a pairing of items from two sets is special if each item from one set pairs with exactly one item from the second set. And in case you are not aware, when you see the phrase exactly one in math, you want to remember that that means one and only one, not two, not three. It has to be one. Okay? Now, a relation is a set of pairs of input and output values, also known as a set of ordered pairs. Now, there are four ways to represent relations. You can have, as we just mentioned, ordered pairs, where you have input and output. You can have what is referred to as a mapping. You can have a table of values, or you can have a graph. Okay, so our first example, the monthly average water temperature of the Gulf of Mexico in Key West, Florida varies during the year. In January, the average water temperature is 69 degrees. In February, 70 degrees. In March, 75 degrees. And in April, 78 degrees. How can you represent this relation in four different ways? So if we think about input and output, or a set of ordered pairs, then we might assign the number 1 to January, 2 to February, 3 to March, and 4 to April. In which case, one way we would have our ordered pairs. So we would say 1, comma 69, 2, comma 70, 3, comma 75, and 4, comma 78. All right, that's one method. The second one was a mapping. Okay, when you have a mapping, you write all of your x coordinate inputs. So I would have 1, 2, 3, 4, and then I have my outputs. Okay, and what are my temperatures? I go from 69, 70, 75, 78, and then you draw an arrow to show what number goes with what. It just so happens these are in the same order, so we get to draw just straight across. Okay? The arrows, as we set up here, arrows show how to pair each input with an output. Okay? Our third way would be with a table of values, x and y. And again, we have x is 1, 2, 3, 4, and y is 69, 70, 75, and 78. And then last but not least, we have a graph. Now you can look at this and say those are all positive numbers. So on my coordinate plane, I'm going to be in the first quadrant. 1, 2, 3, 4. 1, 2, 3, 4. Then we can put a little break in our graph because we're going to start it at 70 and then go to 75 and then go to 80. So at 1, it's 69, so I'm going to graph 1 and go just below 70. At 2, it's 70. At 3, it's 75. And at 4, it is 78. Just some dots, don't need to connect them, but we have represented this relation in four different ways. Okay, so keep in mind your inputs and your outputs are the same as your x and y, and x, as we've mentioned, is the same as your domain, and y is the same as your range. All of these pairs go in alphabetical order. I comes before O, X comes before Y, D comes before R. So hopefully you can remember that the inputs can also be referred to as X, can also be referred to as domain. Outputs go with the Y and the range. Okay? So keeping that in mind, we have a question here. What are the domain and range of this relation? Okay? As we just commented, X is our domain, Y is our range. So my domain, you do need to list these in order, but it's the X coordinates. So the smallest one, I think they're in order as we see them. So we're good with -3, 0, 2, 9, and it didn't go. Oh, -3, 0, 2, 9, and 23. And my range is going to be 14, 7, 0, -18, and -99. So if I write those in order, the smallest one is -99, and then I go to -18, 0, 7, and 14. So we have now given the domain and range of the function. Now, excuse me, of the relation. Okay, that was the relation. Let's talk about what a function is, which is a special kind of relation. Okay, a function is a relation in which each element of the domain corresponds with, here's that phrase again, exactly one element of the range. Okay, so you're looking at it, and you've probably heard this before, but what you're used to is the same x cannot have different y. The same x cannot have a different y value. So I look at this, and you can look at the arrows. Sometimes it's easier if you take the information and write the ordered pairs according to the arrows, or a table, however you prefer. But this first arrow says I have the ordered pair 2, -3. The second arrow says I have 2, 3. And you can keep going. It says 3, -1. But the first two right here should be enough for you to realize the same x cannot have different y values. So the answer here is the relation a function? Absolutely not. Okay, because the same x cannot have different y's if you want it to be a function. Now, if they give it to me in an ordered pair, then I'm going to go look at the first numbers. -7, 9, 14, and 7. Do any of those repeat? Does the x repeat? And if the answer is no, then absolutely we have a function. Yes, it is a function. Holds true every time. Okay? If x does repeat, you need to look and see if you have different y values. Okay? Number 3, how does a mapping, C, not 3, how does a mapping diagram of a relation that is not a function differ from a mapping diagram that is a function? Okay, so we saw this was not a function. What would be different if it was a function? And hopefully, pause if you need to, but hopefully you can see that if it were, the difference being, if it's not a function, or should we say function? Let's go with function. If it is a function, then only one arrow comes from each x. Each element in the domain, however you want to say that. Okay? So, a little bit harder to see to determine whether you have a function by looking at a mapping or looking at a set of ordered pairs. It is much easier to see it from a graph. And I think you're all familiar with what we use to determine if a function is a graph, and it's called the vertical line test. And it can be used to determine if a relation is a function. And the vertical line test says that if a vertical line can be drawn to intersect a graph in more than one point, then the graph is not a function. So what you can do here, you can take your pencil, you can take whatever straight edge that you have to look at. Let's go with, um, let's go with green. Okay, so I draw a straight line. Okay, and I'm going to take that line and I'm going to move it across. And do I ever touch the graph in more than one spot at the same time? Well, hopefully you can see the answer is yes. I touched the graph here and here. So is this a function? No, not a function. And I'm going to take my little line and I'm going to keep going across. All right, I've only hit one. As I go across, I've only hit one. Do I ever hit two at the same time? And I do not. So in this case, it is yes, it is a function. All right, and again, I'm going to go back and move my straight edge. Do I ever touch the graph in more than one spot? And hopefully you can see as we go across that I never touched it more than once. So again, in this case, yes, I have a function. Now we have to talk about a function rule. And a function rule is an equation that represents an output value in terms of an input value. Okay? Again, we've talked about inputs, outputs. In terms of letters, we have X and then we have Y. And in terms of those fancy words, we have domain and we have range. And another word that you want to keep in mind that associate with these is one of them is an independent variable and one of them is dependent. And the independent is the one that I choose, which we usually choose the X to put into the Y. So the X is more oftentimes the independent variable, and the Y is the dependent variable. Okay, so what are you going to have to know about function rules? You're going to have to know how to find the output. Okay, for f of x equals negative 4x plus 1, what is the output for the given input? So all you're going to do is take that value that they give you for an input and put it in where you see x. So f of negative 2 equals negative 4. And remember, we put parentheses wherever we see a variable. And then what am I going to put in? I'm going to put in negative 2. So I simplify negative 4 times negative 2 is 8 plus 1. So I have f of negative 2 is equal to 9. Okay? Sometimes they want you to write it like that. Sometimes you may write it like this. Keep in mind these two are equivalent expressions. Okay, this would be the function notation, and this would be that ordered pair. Still giving me the output for the input. All right, let's go do f of 0. F of 0 says negative 4 parentheses. And what am I going to put inside my parentheses? I'm going to put 0. And now I simplify it. Negative 4 times 0, of course, is 0. So f of 0 is equal to 1, or the corresponding ordered pair would be 0, 1. And last but not least, we have 5. So again, f of 5 equals negative 4 parentheses plus 1. What's going to go inside my parentheses? A 5. And then I'm going to simplify that and say that f of 5 equals negative 20 plus 1, which is negative 19. Again, the ordered pair that goes along with that is 5, negative 19. So there we have summary of relations and functions.